The other part that's in there is just an angles are the two angles are congruent. So you start piecing through this. It's quite literally writing it down. As you're given. And then we mark our diagrams. Okay? Go to the next one. What does your progression sheet say to do when you are given perpendicular? First thing it says is to what? State the right angles that are formed. So when your two lines are perpendicular, AC and BD, then you just look to see where those two lines run into each other, and then you create those little boxes to know where the right angles are. And how many letters do you use for an angle? 3. Okay? So you know that the angles then, if C is going to be the vertex for either one, DCA and BCA are right angles. Definition, perpendicular. After that, progression sheet tells you, state that they are congruent. Because right angles are congruent. Excuse me. Now, according to your diagram, you have two sets of angles. What's left? What's left? It's the only thing you can do now. Nope. You have two angles. There's nothing on here that says two angles. You need another side. Where's the side? Where's the side? Yeah. Not bisect, it's reflexive. Okay. Again, you have a picture of this on your piece of paper. If you're not looking at this piece of paper while you do these things, you're shooting yourself in the foot. You're doing yourself a disservice. Yes, ma'am. You're right. It's okay. We haven't gotten there yet. That's fine. That's okay. I meant to do that because I wanted to make sure I showed you guys that there are other situations that are. I'm sorry. You almost drifted. I thought that was kind of funny. I'm sorry. I didn't mean to laugh at that. I shouldn't. That was funny. You're right. We haven't talked about parallel, and we're going to talk about that today because that does show up with these as well. So last was your AC. Yeah, there's shadows. So lastly, you got then now you have your triangles of angle side angle. Okay. Just don't worry about it now. We'll see it later. And then what was it? And there's your reason. So as you, yes, ma'am. Yep. Yep. Because you've got that reflexive property to throw the side of. Okay. So as you go through it, nothing's changing, guys. You've done this proof a couple of different ways. You've done it with midpoints. You've done the same proof with angle bisectors. You've done this proof now with perpendicular. Whenever you see a diagram that looks like that, you're probably going to have a reflexive side. On your progression sheet, you've got a picture of one that looks just like that for a reflexive side. Look for reflexive, look for that shared side. You have to say that it's there. All right. Also, remember, the only ways to show that triangles are congruent, if you're going to write down this, triangle congruent to some triangle, the only reasons you're allowed to use are one of these 4. If you're not using one of those 4, it's wrong. There are no other ways of showing it. There's nothing. Okay? There's nothing else. I'm going to skip the parallel one for right now. I'm going to come back to that one as the last one because that one we're going to use that one to lead into what we want to talk about today. So the other two were 14 and 15, correct? So you're given that information. You have angle B is congruent to angle Y. And you have a bisector. Given, it's marked. Okay. Go to the next one. What does it say to do for any progression sheet about angle bisector? Actually, you know what? 1 second. Well, hold on. For some reason, I think we don't have angle bisector. We do? Because one of the classes did not, and I was like, wait, what? Okay. Okay. Okay, thank you. I actually went through, and I think it was 9th hour yesterday. We actually didn't have angle bisector. We somehow had accidentally skipped it. But they were like, oh, it makes it's easy to do, but so angle bisector tells you state two angles that are not congruent. So you follow to where VWY is. That makes these two guys the ones that were bisected. So you state what's congruent. Angle BWZ congruent to angle, oops. I went from outside up, so I'm going to go outside up also. And that's your definition. Angle bisector. What was that? Oh, I thought you said something. It depends on what's being stated. I know. There's a lot of stuff that when you look at the pictures, but you have to go with what's given to you. You can't just assume something's there. Okay? The other stuff, yeah, the other one had something else given to you, so you use some other side. You're right that those diagrams are basically the same thing, but we don't know where some of the other values are. I don't know if they're perpendicular to Z. There's no way of knowing that. There's little things that are different. Okay? So it's just one of those. You got to go with what they say. All right. But you're right. A lot of times they all look the same. So what's left? I got two angles. What do I need? A side. Where's the side? Shh, ladies. Can't even hear them. Stop. Yeah. Yeah, that's usually the best thing because once you start going through and you start realizing what information you have, once you had two angles, that means you're either going to use your angle side angle or angle angle side. Because there is nothing that does angle angle angle. There is no such thing. Right? So you had to come up with some side. That's why we go back and look at that diagram. And in this case, it's got that reflexive side. It's got that shared side to it, that shared WC. So you state that it's there, and now all of a sudden, as you go through it, you've got angle, angle, side. Yes, sir. Yeah. Yep. More often than not, yes. Yes, ma'am. Good question. Okay. Let me show you. Let me show you what happens. If I say that all three of these angles are 60, what kind of a triangle is that? Equilateral. Okay. Equilateral triangle. Okay. Now here's the thing. If I take this, those angles are still the same, aren't they? Are those triangles congruent? How in the world are those two the same? That's where we get. There, you have what's called similarities between triangles when the angles are all congruent, the sides aren't. If the sides are proportional, then they're similar. Between two equilateral triangles, they will always be similar because your angles always match up and the sides will always be the same. So if this side length here was 3, that means all of these are 3s. And if this is all 9s, these are all 9s. Okay. So if you talk about the ratio, like you're saying, similarity, which we get to later on, the ratio of the sides would be 3 to 9, 3 to 9, 3 to 9. All of those fractions simplify out to be the same thing, 1/3. You get what's called a scale factor. Okay, that's something we talk about. It's chapter 6, right before finals. We get to this. It's a very, very easy. It's a very easy chapter. Yep. Yeah, we're. Okay. Yeah, that's why there is no such thing as angle, 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 but there is what we call angle, angle similarity, and that's where this comes in. Good question. All right. So back to this one. Anytime that as you're going through, this is why I keep telling you guys to draw your pictures, fill in the blanks of the diagrams, because as you're seeing what you're marking up, you're starting to figure out which of the 4 you're going to use. That's the trick. That's the trick for these things. Okay, please stop it with that. It's driving me nuts. Thank you. Stop it, all of you. What stinks with number 15 is that you have 3 progressions, and 2 of them have 3 steps. I have 2 of them that have 3 steps because they're 2 sets of perpendicular. That gives me 6 steps out of that. The next one has a midpoint, which has 2 steps. There's 8 steps right away that I can see from my givens of writing things down. But everything is in front of you as far as how it works. You just have to write them down. So as you go through, PQ, perpendicular, QS. That means what angle is a right angle? I'm looking at PQ and QS. What angle is the right angle? Can I just use Q? Is that okay? Why is it okay that I use just angle Q for this? It's just, there's just one vertex, so it's okay. So I can say then angle Q is a right angle. You cannot say angle T in this case. I know where you're going with that. I can't say anything else about this right now because there's nothing else. Put the water bottle away, please. Stop. Yes, just stop. So you go to the next one. That's how you have to get the other part to show up. And now you have angle S as a right angle. Now that you have 2 right angles, that's when you state that they're congruent to each other. It's a little bit different than the one that we did first, where it was perpendicular between the segment, where you were given that you could draw up 2 right angles right away. In this diagram, you're only going to get 1 angle at a time. No big deal. Everything's off of your sheet. Everything's off the sheet. You go to the next one. If T is the midpoint of PR, you go to the segments now and mark which ones are congruent. Well, T is the midpoint of PR. PT, TR. And now you look at your diagram. As of right now, you have one angle on one side. So you have the possibility of using side, angle, or angle, angle, side. In this diagram, there's one thing now you can infer. What is it? Your progression sheet has a picture of that. It should not be taking this long to answer these questions, guys. You've been looking at these same pictures for a little while now. Come on now, we can do this. There's a picture that looks like that. It tells you look for something. What's that? Perfect. Get vertical angles. Remember the bow tie thing again? There it is. You have vertical angles around T. So if I say angle P, T, Q, it would have to match up with R, T, S. Which of the three do we have now? We have two angles in a side. Is it angle, side, angle, or is it angle, angle, side? Very good. Yep. Technically what? Yeah, there's nothing else in there. Does it say it? Assume it. You have to go with what's given to you. The only things you're allowed to, I wouldn't even say is assume, but the only things you're allowed to infer are things like reflexive or vertical angles. Those are the only things you can infer from a diagram. You cannot just say, oh, they kind of look the same. Can't do it. Yes, sir. Look for vertical angles. It might look like an X.
Oh,
And then the last one, let's talk about parallel. And that's the one that I want to lead off with today.